In this video, we will practice factoring a variety of polynomials.
Okay. Looking at number 12, well, really, before I factor this, I'm going to write it in standard form. So in standard form, the higher degree terms will be first. It'll be in descending exponential order. So the negative 4x squared really belongs in front, and then followed by the negative 5x, followed by the positive 6. Now another thing I'm going to do, as soon as I see this negative sign out front, before I start factoring, I'm going to factor that out. So I'm going to take that negative sign, put it out in the very front, and then that's going to leave behind 4x squared plus 5x minus 6. So just change all the signs. And then I will factor as usual. So considering that I have a quadratic trinomial, you know, it's x squared, quadratic, whenever I see that, my only shot at factoring this is that it will be a binomial times a binomial. So let's see, 4x squared can either factor as 2x and 2x or x times 4x. So I'm going to start off with 2x times 2x. If this doesn't work out, I will go back and do the 4x and x. So let's see. Now looking at the 6 can factor either as 2 times 3 or 1 times 6. Okay, now neither one of these are going to work with 2x and 2x because there should be no common factor inside of either set of parentheses. If I do 2 times 3, that creates a common factor right here. If there was no common factor in the previous step, there should be no common factor in either parentheses. So I know that this will not end up working. Okay, so that means that the 2 times 3 won't work. If I try to do 1 times 6, now that will create a common factor between the 2 and the 6. Both of these are divisible by 2. So that won't work either. So that tells me very quickly that the 2 times 2 option won't work. So I will abandon that. Instead, it must be the x times 4x option. Okay, now I'm going to go back to my 2 times 3. Again, the order matters. For example, the 3, say if I went 3 here and 2 here. Again, this would not work because this would be a common factor. There's a common factor here, and there shouldn't be. So I wouldn't waste my time on that. I would go straight to this option. 2 and 3 is the only hope for this version. Now, inner plus outer equals middle. Inner, I have 8x. Outer, I have 3x. I'm trying to get 5x, middle. So if that would happen if I had a positive 8 and a negative 3. So a positive here will give me the positive 8, and a negative here will give me the negative 3x. Also, positive 2 times negative 3 is negative 6, so we have a winner. And that's it. So we have factored the trinomial. All right, looking at number 13, this is just good old difference of two squares. All right, 25 and 4 are both perfect squares, and I have x squared. So this will just be 5x plus 2 and 5x minus 2. Difference of two squares. 5 times 5 is 25, 2 times 2 is 4. Make 1 plus and 1 minus, and boom, you're done. That should be quick and painless. Okay. Number 14. As soon as I see 4 terms, I'm going to try grouping. So I'm going to group these two, and I'm going to group these two. The GCF of the first pair is 5x squared. So I'm going to pull 5x squared out. And I'm going to see what does that leave on the inside. Now, if you need to, if it helps you, you can think of it this way. Whatever is this GCF, if you want to know what's going to go inside the parentheses, just divide by the GCF. So I could think of it as dividing by 5x squared in both places. Okay, 10 divided by 5 is 2. X to the third power divided by x squared is x. And then here, 5x squared divided by 5x squared is 1. Anything divided by itself is 1. So that's something you can use if you need it. Okay, the common factor here is 2. Well, negative 2 because of the negative sign. So I'm going to pull out a negative 2. Okay, so that's going to leave me with 2x plus 1. And again, if it helps you, think of it as dividing both of these by negative 2. So that's going to give me 2x here and a positive 1 here. Notice that what's in the parentheses is the same thing. That's necessary for grouping. So that makes 2x plus 1 a common factor which needs to be pulled out. So I'm going to factor out 2x plus 1 and put it out in the front. Okay, that's going to leave behind the 5x squared and the minus 2. So I have 5x squared and I have minus 2. I will examine this carefully to see if it can be factored more. It cannot. For example, if this were 9x squared minus 4, then that would be the difference of squares, but this is not. So this is the final answer. Okay. Now, look at number 15. The first step of factoring is to look for a common factor. And it doesn't necessarily jump out at you immediately, but these two numbers are both divisible by 3. Okay, one thing that I learned back in elementary school is that if you want to check to see if a number is divisible by 3, add up the digits. Like, for example, 7 plus 5. 7 plus 5 is 12. 12 is divisible by 3. That means 75 is divisible by 3. All right? 48. If you add up the digits. 4 plus 8. Well, also 12. That's divisible by 3. 48 is divisible by 3. So both of these numbers are divisible by 3. So if you take out that common factor of 3, what's going to be left behind? All right, of course, that'll be 25a squared minus 16. Now examine this binomial very carefully, and you will see that this is the difference of two squares. So this needs to be factored more. And very quickly, this will become 5a plus 4 and 5a minus 4, all right, using the difference of two squares pattern. All right, so this will be the final answer for number 15. For number 16, we once again have the difference of two squares, so that's going to factor nice and easy. 100 is 10 times 10. So we will have 10x, well, you know what, skirt, slow down. The first step of factoring is to factor out the GCF. 25 is a common factor, so the first thing you should do is factor out the 25. Okay, so that's going to leave behind 4x squared minus 1. Now, we still have the difference of two squares, but it looks a little bit different. So we'll factor the remaining quadratic binomial as 2x plus 1 times 2x minus 1. This will be your final answer. Okay, again, 4 is the GCF here. So you should factor out that 4 before you do anything else. So that's going to be x squared minus 16. And then again, this can be factored further as the difference of two squares. X plus 4, x minus 4. So this is the final answer for number 17. Number 18. All right, even though this has a fourth power here, I see that we have a trinomial, and we may be able to factor this as a binomial times a binomial. X to the fourth power will factor as x squared times x squared. 36 is going to factor as either 6 times 6, or it could factor as 4 times 9, or 3 times 12, or 1 times 36. But keeping an eye on the 13, I'm thinking 4 times 9. Okay, to get a negative 13 in the middle, both of these need to be negative, because inner plus outer equals middle. Inner, I have 4x squared. Outer, I have 9x squared. If both of these are negative, that will make negative 13x squared. And negative 4 times negative 9 is positive 36. So that's how this factors down. Both of these are in turn the difference of two squares, so both of these will factor down further. All right, x squared minus 4 will become x plus 2, x minus 2. X squared minus 9 will become x plus 3, x minus 3. So this is the final answer for number 18. Okay, number 19. As soon as I see that I have a 4-term polynomial, I'm thinking grouping. So the GCF of the first pair is x squared. So I'm going to take x squared, pull it out. That's going to leave behind 3x plus 2. Now, the GCF here is negative 4. You have to deal with the negative when there's a minus here. So, negative 4. If I factor that out, that's going to leave behind 3x plus 2. Again, imagine doing the distributive property with negative 4. Negative 4 times 3x is negative 12x. Negative 4 times positive 2 is negative 8. So it checks out. Notice how the parentheses are the same. That is necessary for the grouping method. Now, 3x plus 2 is a common factor which must be factored out. So I will factor out the 3x plus 2, putting it in the front. If I take these two away, that leaves the blue stuff behind. That leaves behind x squared minus 4. All right, now, this is further factorable as x plus 2, x minus 2, since x squared minus 4 is the difference of two squares. So this is the final answer for number 19. Okay, number 20. Again, I see the 4 terms. So again, I'm thinking grouping. Let's see, the GCF here is going to be 80 x to the 4th power. All right, that's going to leave behind x squared plus 1. The GCF here is 5. if I factor out that 5, that's going to also leave behind x squared plus 1. Notice that the parentheses have the same thing, x squared plus 1. All right, that means x squared plus 1 is a common factor, which we can factor out and put in the front. If I take the x squared minus 1 away from each part, that's going to leave behind the blue stuff. That's going to leave behind 80 x to the 4th power plus 5. Neither of these can be factored anymore, so this is the final answer. Okay, 21. This is the difference of two squares. All right, if you have a variable and any even power, whether it's 2, 4, 6, 8, 10, 12, that's a perfect square, because x to the 6th power can simply be written as x to the 3rd power times x to the 3rd power. So this will be x cubed plus 1 times x cubed minus 1. Uh-oh, I'm going to need more space. In fact, I'm going to color coordinate this because of the next step. You might have been thinking that you were done, but you would have been wrong. Because we also know how to factor the sum of two cubes and the difference of two cubes. So both of these are factorable further. So that's what we're going to do. Okay, so let's start with the blue side. I'm going to have to put it down here because it's going to take space. Okay, it's going to take space. So looking at the blue part, when you have the sum of two cubes, that is going to factor as a binomial times a trinomial. So the binomial is just the cube root of these. So the binomial will just be x plus 1. The trinomial, you know what, I think I need a little bit more space for the trinomial. All right, if I square these, I'm going to get the first and last terms of my trinomial. In the middle, you multiply these. 1 times x is just x. But you do the opposite sign. Sometimes we think about the acronym SOAP to help us remember how the signs go. Same, opposite, always positive. So that's how you factor the blue side. Similarly, I will factor the red side. Again, the difference of two cubes will factor as a binomial times a trinomial. The binomial will be the cube root of these, so that will just be x minus 1. If I square both of these, that will give me the first and last terms of the trinomial. So this will be x squared and plus 1. If I multiply these, it will give me the middle term. 1 times x is x. All right, but we must do the opposite sign. So this is minus, so I will put plus. The acronym SOAP helps us remember how the signs go. Same, opposite, always positive. And that is it. This will be the final answer.